So what I want to do with this function is I want to find all the real zeros. And we want to follow those 4 steps that are listed out on your sheet of notes. It was decide how many zeros there's going to be. Okay, so there's got to be at least 4 complex zeros, so some of them could be imaginary. And then it was graph it, find what I call the easy zeros, that would be the rational or the integer zeros. Divide those out using synthetic or long division. And then hopefully you get down to a quadratic where you can use a quadratic formula or your other techniques for solving quadratics from there. So I already graphed this. I found that the function crosses the x-axis at x equals 4 and x equals negative 5. Okay, so that tells me that, so I guess let's write that down, x equals 4 and x equals negative 5. So those two zeros I'm going to use to divide out the factors x minus 4 and x plus 5. Okay, so those are 2 factors of the polynomial. I'm going to divide those out. So let's use synthetic division to do that. So I'll put the 4 in the little box. I'm going to list out the coefficients. Every power is accounted for here. So I don't need a 0 as a placeholder, so I'll just write out the coefficients. 1, 1, negative 17, 3, negative 60. Draw the line, bring down the 1. 4 times 1 is 4, add them up, that's 5. 4 times 5 is 20, add them up, that's 3. 4 times 3 is 12, add them up, that's 15. 4 times 15 is 60, and I get 0. This 0 implies that it is a factor. We thought it was a factor, or knew it was a factor from graphing, but this confirms it here. Now we're going to divide up the negative 5. To do that, I'm just going to take the same line of coefficients here, and I'm going to put in negative 5. All right? And then we'll do the same thing, synthetic division again, with the numbers that we've got right here. So I'll bring down the 1. Negative 5 times 1 is negative 5. Add them up, that's 0. Negative 5 times 0, that's 0. Add them up, that's 3. Negative 5 times 3, that's negative 15. Add them up, again I get 0, indicating that x plus 5 is a factor. We knew that would happen. If it didn't happen, then we would have done something wrong in the synthetic division. We would have had to go back and do it again, all right? But it didn't, so just to kind of lay out what we've got now, we started with a 4th power polynomial. We divided twice, so that's going to depress the degree of the polynomial by 2. So this will be a quadratic. In other words, this other factor here is x squared plus 3. In other words, if I was to write out the whole thing, everything we know at this point, we'd write this, that we know that x plus 5 is a factor, x minus 4 is a factor, and x squared plus 3 is a factor. So this is f of x. Okay? So we know that those things are factors. We know 2 of the zeros, x equals 5 and x equals 4 and x equals negative 5. We need to figure out what the other zeros are. So we're going to take this other factor that we just found here, x squared plus 3. We could use the quadratic formula, but it's easier, I think, just to use what we know about just solving equations algebraically to solve this. So we'll take and set x squared plus 3 equal to 0. So where should we do that here? Right here. X squared plus 3, set it equal to 0. Move the 3 over, so I get x squared equals negative 3. Square root, don't forget it's square root of a variable, so do plus or minus. So I get x equals plus or minus square root of negative 3. We're going to write that as I times the square root of 3. All right, and that's our other two, the other 2 zeros. They're complex numbers, they're imaginary. So we'll list those out too. So x equals I root 3 and x equals negative I root 3. And that's it. So we just follow that process and we get all of the zeros. We anticipated 4. We found that there were 4. 2 of them are imaginary numbers.